Welcome to the Machine Learning Security panel of the Machine Learning Integrity Conference. My name is Hyrum Anderson. I'm a distinguished engineer at Robust Intelligence, and I'll be facilitating our panel discussion today. And it's my honor to be joined by four exemplary leaders in this space. Vijay Bolina, the Chief Information Security Officer from Google DeepMind. Yassir Nawaz, Managing Director of Emerging Tech Security at JPMorgan Chase. Merritt Baer, Office of the CISO at AWS, and Shankar Siva Kumar, Principal Program Manager in Azure Trusted Machine Learning at Microsoft. And before we dive into our discussion topics today, I'm going to invite each of our panelists to share just a few points of context about their role in their respective organizations and how it might relate to security and machine learning. So why don't we start with you, Vijay, then Merritt, then Ram, then Yassir.
Great. Hey, everybody. I'm Vijay, and I'm the CISO over here at Google DeepMind. I'm accountable for addressing the emerging risks in the intersection of safety and cybersecurity of long-term AI systems. Happy to be here.
Hi, folks. This is Merritt Baer. I am coming to you from Miami, where we are on Tequesta, Miccosukee, and Creek land, among other nations, and wanted to talk today about some of what we're seeing both in sort of the promise and some of the ways that we are hedging against security implications of machine learning and sort of its downstream elements, including ideas around artificial intelligence. I work in the Office of the CISO, Chief Information Security Officer, here at AWS, Amazon Web Services, or the cloud. And in that, I sit in AWS security, help us secure ourselves, but also talk to customers about how they can be secure and about how we can help us refine our delivery of products in a secure way. Thanks.
Everybody. My name is Ram. I actually sit in the land of the Duwamish people. And, I co-lead the AI red team at Microsoft. So our goal is to assess the security posture of Microsoft's critical machine learning systems. And Hyrum did our first AI red team exercise not too long ago when he was there with us. So excited to kind of, get back with this esteemed panel.
Hi, everyone. My name is Yassir Nawaz. I'm part of global cybersecurity within JPMorgan Chase, and I'm responsible for securing emerging technologies within the bank. So my team is responsible for securing all of the AI and ML platforms in JPMorgan Chase. Being one of the largest bank in the world and highly regulated entity, not just in US but all over the world, we have some unique challenges, and we're trying to figure out how to secure machine learning, but also how to do it in a way that allows not just our regulators but our customers and society in general confidence that we are doing it in a responsible manner. So happy to share my thoughts on that.
Excellent, thank you. To introduce our discussion today, even mature organizations are still working with the best practices to secure systems, and it seems nascent. But in our panel today, I'm hoping that as we talk about some of the risks of machine learning, I'm going to also ask our panelists to provide recommendations about what we can do today to manage that risk, so it doesn't seem so far off and aloof. So to the audience, we do anticipate using all of our allotted time on questions that I've prepared. However, if you have specific questions for a panelist, I'd encourage you to leave those in the session chat, and if time permits, we will get to them. So for our first topic, I want to talk about the kind of risks that the security that we inherit in machine learning from software. So there are bugs in software, there are software development practices in software, there are organizational structures for dealing with this in software, and we inherit those in development teams. So in honor of Cybersecurity Awareness Month, I want to first have each of you address kind of the fundamental cybersecurity that's important for companies who are now adopting AI at a feverish pace. So I want to begin with you, Ram. There's been this massive democratization of AI development. It's no longer just machine learning engineers, but application specialists doing AutoML or other things. What are some of the traditional software considerations, the traditional practices that developers of the machine learning model should be aware of?
Yeah, and I'm actually quite excited to also hear like Vijay's thought on this because he runs like literally he's for the security of Deepmind as a whole. For me, the big thing that I think about is data supply chains. There was a viral video that Yannick Hilcher kind of had showing like how pickles and ML models can essentially be have malware embedded in it. But this is something that the security community has known for a long time, like serialization bugs. So it almost felt like a renaissance for the ML community to wake up to this new sort of vulnerability. And I love the word that you use, Hyrum, that's inheriting. So I think a lot about people going to Hugging Face and downloading like random models, people kind of like installing third-party software that may not necessarily be patched, thinking about what are the vulnerabilities in ML platforms like Databricks or Spark or any of those nascent libraries. So that's what I think a lot about, especially when it comes an immediate thing when it comes about software vulnerabilities.
Vijay, you've been tapped. Do you have anything to add?
Great. So +1 to everything Ram just mentioned, but yes, at a high level, I think to a certain extent, best practices that we've learned over the course of the past few decades now, from a software security standpoint, can be applied to machine learning engineering and to a certain extent, even data science teams. And this could be more traditional things like threat modeling or vulnerability management or pen testing and things like that. I think with machine learning and data science teams specifically, though, you should be mindful of what the data team has access to and what the data is being used for in production machine learning systems specifically. And things like knowing what types of data may require certain guarantees from a privacy standpoint, as an example, and understanding, what specific iteration of a data set a model was trained on, are being able to track provenance to a certain degree as well. And now, if your data science teams have the ability to modify or curate data, as an example, what are the methods that you have in place or the controls you have in place to ensure you have better visibility of who's changing what and doing what, and similar to versioning system in software. And I think also from a more traditional sense, and lastly, the third-party dependencies or supply chain vulnerabilities are obviously top of mind. Ron mentioned issues with pickle and things like this. These things are going to exist in our ML infrastructure, and we have to be mindful from a supply chain standpoint where those weaknesses are and what types of things from a process or a control standpoint we have to stay on top of those types of issues, whether it's purely doing analysis or research or serving actual production workloads that may be serving some type of model to some set of customers or an external interface.
Excellent. Staying on the theme of the fundamental cybersecurity things that machine learning engineers, data science teams can do. Merritt, do you have advice for companies who are adopting AI? What are the things they should never abandon? What are those things that are going to be good for them to continue on as they adopt kind of a new frontier for their development?
Well, first, and I guess you're probably not going to be surprised, I think we need to define AI. Like a lot of times folks use machine learning and artificial intelligence interchangeably, and that is not a precise way to talk about this area of computer science. We should be thinking really in terms of where we are today when we talk about the ways that we can approach the kinds of issues that we know to be out there, everything from, as folks have mentioned, software provenance to algorithmic integrity, which includes everything from like degradation to deliberate poisoning. Like we should be talking about the world as it is and envisioning it as it may become. But AI, in my view, is what it may become and not the world as it is today. So I don't think there's any sort of autonomous, self-thinking machine out there. I think these are all programmed, which is why, or like I believe this much to be true, which is why there is so much need for us to do our work in ensuring that we remove as much sort of human imperfection as we can. So this may take the form of doing, what is increasingly doable in the form of like automated code reviews through things like Code Pipeline and Code Guru and all the open source tools. But it also means that we need to have processes and not just tools that ensure that we look at the ways that we are injecting anything that is external in the form of data that trains these models and that, assures us of some validity that then we're just comparing against a statistical assurance, right, of how good we think we need to be for this. So kind of like the right tool for the right job. And I think in practical terms, we need to be looking at both those technical tools and the ability to do, kind of the underlying theme of what we've all mentioned here is like moving to cloud is going to give you a lot of returns on this. You can just power up a lot of compute and a lot of, algorithmic forebears who worked on this before you, but also then taking advantage of the ways that you as an entity can shore up what you know to be true. Think about how I'm sure all folks on this call and others in the audience, how they inspect like code injections, right? And the ability to scrutinize those and kind of the layers of scrutiny that we put on those. Compare that with how data often comes in that then trains or retrains models. Like we need to be thinking more, I think, in terms of what is external, what is internal, how they can be more thoughtful as we inspect those. And then also, what degree of certainty do we need? Like, is it enough to know that this is a banana, or do we need to know whether it's in the road or whatever? Like there's all sorts of scientific studies about like, the AI algorithm that identifies a couch as an elephant, or you know what I mean? And to some extent, sometimes we don't need to know more than there is an object in that room. And other times we need to know very specifically, like these are the irises of, this individual. And so I think as we sort of tune and refine our models, just thinking about how we get those inputs, how we train those models. And of course, another underlying element here is hiring and retaining diverse talent, because you're going to have folks who think about this. I think often we think of the term bias referring specifically to folks who identify with different parts of the population, and that is true. But we also see that just sort of what we think of as mathematical biases, blind spots and things that we aren't addressing well enough are problems to be solved that get better addressed by diverse folks who get in the room and think differently.
Merritt, I'm so glad you brought that up. It's not just about tools, but it's about people and processes. And Yassir, you've been thinking about the bleeding edge of security for a long time. What place do people and processes have, especially as it relates to adopting AI in organizations? Can you provide us your thoughts?
Yeah. By the way, I agree with everything that Ram, Vijay, and Merritt said. Like to your point, what we found is that because we have a very mature, by we I mean as an industry, a very mature software security practices and processes that we have developed over a long period of time. And what we discovered was that starting from that, leveraging those to basically build a governance over the entire end-to-end machine learning and AI development process helped us. And part of the reason is that, being a highly regulated bank, we have to sort of, think about compliance, think about, being able to explain, how we are securing, the models that we are building and what frameworks we are using. So instead of just starting, with something completely new, starting with something that is mature, and we know works, and then adapting it to the ML delivery process, we found that has been very helpful. So if you look at the controls, just to give you a few examples, right? So we have data controls. Every organization has data access controls, data protection, data use, data loss prevention. We have very mature sort of supply chain processes for bringing in software. We have very mature CI/CD pipelines, with controls built in. Ways to prove the integrity of the entire process. So being able to leverage all of that, I think, is very powerful. And now, these controls may apply slightly differently. Your process may be slightly different, but essentially, at the end of the day, most of these controls, we just need to make sure how we inject these controls into the end-to-end process. And I think we have a very good foundation on which to then build on and address sort of the emerging threats in the area. So that's how we have been thinking about this, JPMorgan.
No, I think if nothing else, if companies adopt fundamental cybersecurity, they at least have a solid foundation on which to build. But there's also a host of additional new risks that come as people adopt AI, and I want to address that in our next series of questions. These novel security risks exposed by the presence of a machine learning model. Those are both philosophical and specific. But maybe Yassir, let's start with you again, and we'll let the other panelists jump in. What are some of those novel security risks that companies should consider when they're adopting machine learning as a core piece of their company?
Yeah, so I look at it as, the risks that are not, in the category of, let's call it adversarial machine learning, but more about, risks that are traditional risks, but they are more relevant, or they are relevant because we are trying to do things in a slightly different way. I'll give you an example, right? So for example, if you look at our controls today, most of our controls often, are, scoped by data classification, right? So you look at it for public data, I have these controls. For confidential, highly confidential, I have these controls, right? So, but often you find that if I'm using public data or data with lower classification to build a model that is very critical to my business process, it's very important to then treat the controls around that data, even though data is public, very differently, right? So similarly, if you look at how we govern access to the production environments and to production data today, right? It's very different from what the developers, the data scientists need to do, right? They need access to those production data. So I think some of these risks, are because we're trying to do things slightly differently, but they are not necessarily new things, and the risks are known, but they just manifest themselves, differently. So we need to think about that. And then I think the new and emerging sort of threats are, in the supply chain. It's not just the software supply chain; it's also the data supply chain, right? So things around data poisoning. Can I trust the data that I'm using to trust my model? That's sort of the fundamental question that people need to ask. Similarly, most of the models today, the way they're used, you will have a human in the loop. Right, but more and more these models are embedded into the applications where we don't have a human in the loop. And what does that mean, right? How do we now protect the model against sort of the adversarial input, and what does that mean, right? So some of the attacks that Merritt talked about malicious inputs, that can cause the model to misclassify. Maybe inference attack, which would allow an attacker to basically, repeatedly being able to learn something about the model, what sits behind the model. I think those are some of the things that we have not looked in the past, and they were not necessarily relevant, but now they're becoming more and more relevant, and I think will be more relevant in the future. So I think that's, what I was referring to when I said sort of, once we get the basics right, then we have to start looking at those advanced threats and the emerging threats that we have to address.
Vijay and Ram, I invite you to jump in. You're both at companies, Vijay in particular, you just build machine learning models. That's what you do in your company. What are some of the novel risks that you would suggest that organizations look into?
Yeah, I think I have a similar framing here, similar to Yassir just mentioned. That's what are the risks caused by models in the wild? And at a very high level, right, there's a proliferation of language models and diffusion text and video models that, are inherently and could inherently introduce harms from things like synthetic media and issues with what that can cause downstream if it was abused, and the growing concerns around these types of technologies as they proliferate, and the possibility of a world where we may not really be able to tell the difference between what is real and what isn't. I think at a high level, we at DeepMind, and I know other places too, are thinking about these things as well. Now, then the other way that we think about this as well are things that we're talking about right now, and these are risks that models face in the wild right now, right? And you have the general class of attacks and things that we've been chatting about, like ML supply chain and CI/CD concerns and things like that. And knowing their data, knowing their model, knowing their stack and its associated dependencies and things like that, and or model-specific manipulation or extraction risks and things like fooling a model with adversarial examples or stealing the model itself with careful probing and things like that. On the data side, manipulation or extraction attacks and things like having a model, language model, leak private information, all of which we've kind of seen already now. And, I think in general, though, it's akin to computer security risks is that it seems like there may be, we're at a state where it may be generally, it may be the general consensus that it's quite easy to fool a model, but much harder to kind of protect it. Yeah.
I love the framing that Yassir and Vijay have kind of laid out, especially when it comes to protecting the models and monitoring for it. I'd like to pull the thread a little bit more on response. So for our SOC analysts, after a red team exercise, we asked them, how would you go about, responding to such an attack? And they were like, wait, what? So the response team for the most companies that we have even interviewed just beyond Microsoft are really not prepared for this type of novel attacks. In fact, it's really difficult to remediate attacks on machine learning systems because a patching strategy does not exist. So for instance, if you find that your ML model is vulnerable to say adversarial examples, what are you going to do about it? There's no specific patching strategies that's been outlined. So one thing I'd also love to kind of discuss is what would be some guidelines for us to think about with this in terms of novel risk. You simply cannot patch, data poisoning or adversarial examples or model stealing types of attacks. Then what do we do in that case? And I feel it's kind of like an open question that we should all be wrestling with as well. So just to add to the protect, detect, and respond framework.
Rob, would you mind, peel the onion one layer? What are some of the, specific things that one can do for an evasion, for a model inversion? Would you mind just peeling the onion a little bit?
Totally. I think the first thing that, in the hierarchy of needs, from a security incident responder, you first want to have, the table stakes. And this is nothing new, just having an inventory of all the ML models that you have. So, you know which ones ML models constitute a hierarchy within an AI system. So you want to first have an inventory of all the AI systems and the constituent ML models that comprise. If you think of and then the second thing you want to empower your organization is to have a bug bar. And this, again, traditional security speak. Anytime there's an incident that comes in, every organization will try to slot it into, is this a high, medium, low? And, and they all have SLAs attached to it. They have all playbooks attached to it. Their whole ML model kind of leaked via a GitHub endpoint misconfiguration. that would have a very separate response from somebody trying to, like what Vijay kind of mentioned, like algorithmically probe the ML model and try to reconstruct it. So even when you peel the model stealing onion a little bit layer, is it like a traditional vector or is it a novel vector? And that'll also have, different instant response processes. I think this is a very, big company like point of view. I think if you're a small company that's using, say, an API that's machine learning as a service, or you've just downloaded BERT and you're kind of like fine-tuned it for your specific application, it's going to look different again. So to just roll back all what I said, think of response as something other than, as you think about protect and detect, which Yassir and Vijay kind of outlined, think about response. In response, think about the processes that align very closely with your existing security process. So think about bug bar, think about playbooks. And when you take in stack rank all the attacks that are important for organization and try to peel the onion a little bit more in the context of, is this traditional vector or is it like an ML specific vector?
Excellent. I want to finish this layer of the onion by turning to you, Merritt. So Ram brought up response. He brought up security incidents now are flowing to the SOC. Maybe someday those will include incidents against machine learning. For example, your model looks like it's being probed for model theft or something. How should an organization think about stack ranking priorities? Already, security teams have a ton of different sort of different flavored security alerts that they're worried about. What's the process to work through this this ranking and remediation and actionability process?
Well, I think this has been another underpinning theme that we haven't outwardly acknowledged, which is that we are talking about the security of ML models, but you can also use ML models for security purposes. And we all do. And if you are running on Google Cloud, Azure or AWS, then you are too. And if you're running your own, you probably are doing some other, like some version of it too. So I think, as we think about, I guess this is a little dash of optimism in here, but as we think about ML security, part of it is how we are using ML in security to extract insights, to take action upon them, to identify anomalous behavior. This is part of the beauty of cloud, is that everything is an API call. And so you have this vast swath of data. So like, for example, in AWS, right, we have guard duty that's doing anomaly detection and is kind of pre-programmed with a lot of our internal insights. And then we also have just like every call to KMS. So if you're using encryption, our key management system, that's going to show up as an API call. So you also have the ability to architect on your side to identify behaviors that look anomalous, or to prescribe against them authoritatively, or to alarm on them, and so on. And so you have this texture that's at your, at your fingertips if you're a programmer, or in your mouse click if you're in the console person. But anyway, you have this inheritance that you're kind of getting in the form of ML that is for security purposes. And I think that's helpful to keep in mind, that this has been a useful tool and technology element of security teams in various stages until today, where we continue to see increasing refinement of those. I think as we think through, our stack rank of security concerns around our ML models, I return to the idea that we need to have processes that allow us to notice when it drifts. So when we see, injections coming from, unexpected places, it may just trigger an alarm, or it may trigger us to stop allowing those. It looks, I think, at this stage, at least, it looks a lot like an AppSec review process, where one layer of it, and today in most teams, AppSec does not include a lens around the security of your ML models, but I think it should. So I think that, that's one sort of active measure that folks can take, which is to embed this in the processes that you have around the security that you allow, or like the the ways that you bring things to fruition that then go through existing models, add the security of your ML models to your lenses that you apply. And I think, there's never going to be a perfect sort of like end state here. We're talking about things that are processes and that get better over time. And we try to figure out what we know to be unintended outcomes. But there will always be some effort here that's sort of like abstracted. And that's kind of the point, right? Because we don't want to dig in the weeds for every little needle in the needle stack. So I think, like accepting that we need to pay attention and also take advantage of the security benefits of ML here. There's a marriage there, and having those teams, I think it's also just like, again, I guess folks use the word culture when I think what they mean is like, go do it. Or at least what I mean when folks ask me about culture, I'm like, yeah, you get culture by doing it. So, having a culture where security teams talk to ML teams and have ML folks on the security team and so on. And so, like where you're not talking about diversity, you're doing it. Those kinds of things will all help these processes improve.
Merritt, I feel like in a little bit of our panel discussion today, so many folks who are dialing in are from machine learning teams. And here we are talking in this entrenched security speak. We're talking about processes and tools that probably sound, like totally foreign, maybe not totally foreign, but not day to day for somebody who is training a model, building a pipeline. I want to just quickly turn to try to make it real for those folks, the folks who are not security engineers, not on the security team. They're on a machine learning team. They're a machine learning or an application manager. One question that came up from the chat we'll address today is for the panelists, what are some of the gaps that you noticed today in the machine learning building pipeline that could be improved in their security? Something that would cause an alteration in the outcome of the machine learning model or some security violation. What are things that development teams can pay attention to today in that pipeline?
I mean, part of this, again, is just like how well you can accommodate what you want to exclude and what you don't. Like, as folks know from statistics class, right? The first thing you do is exclude outliers because they're just going to mess with your model. Well, guess what? In security world, we're always looking at outliers. Like, we are focused on zebras and not horses a lot of the time. You know what I mean? And so it ends up being, I think it's true that like we need to talk to each other as communities. And this is a space that I anticipate will be even more robust in the next few. Do you like my nod to you? No, I'm just teasing, but like we'll be even more appreciated in the coming years because I think we're still, building that intersection or that dialogue back and forth around what it will look like to do, mature, secure machine learning, and also to do machine learning for security in a way that is hopeful and not locking things down. You know what I mean? Like I get so sick of the idea that security teams are like the antithesis of progress. Like we have moved on, like any good app dev or ML dev or whatever today knows that like security has to be part of what you're delivering. And part of security includes the faith that from a data perspective, you can put in the integrity of your model. And that means it might be around precision, but like that precision encapsulates the idea of security and, knowability and all these other things. So I think that, this is a little bit of a call to action, but like we need to work on how to better weave these together. But I think they're already looking at each other, and we are working on. And this is, at least I will say, and I think other folks on the panel would agree, like this is something that we are also articulating as we go, right? Like we're getting better at it. We're open to ideas. If you know how to do this perfectly, come talk to us. But like we refine, we get better over time, and we see what works, and we hope that we are getting it to the kinds of stages that are both useful and self-aware.
Others, thank you, Merritt. Others, what would you say to the data scientist, the machine learning engineer, the simple things to do to improve security today?
Yeah, so I guess first I just want to, say that I completely agree with Merritt. Like in my conversations when I, got into this, we had some interesting conversation with our data science community. But over time, what has happened is that, we realized that we're both integral to each other in the sense that actually I'm their customer. They're my customer and I'm their customer because I'm using their platforms to basically, build model for cybersecurity, right, to improve our processes. And I think that sort of, engagement has led to the understanding that, like we need, to what Vijay and Ram said earlier, right, there are sort of your traditional attack vectors, but then there are attack vectors that are leveraging, machine learning and AI, and we need to be able to leverage machine learning in order to build defenses against that. So I completely agree with that. Now, coming back to what you said about, some of the things that, a data scientist can do today, I will go back to, before we get into sort of the advanced stuff, right? There's a basic things around, I said, around basic data controls, basic software supply, supply chain sort of attacks. I think to me, that's where most of the risk is at this point in time. If we are bringing models from Hugging Face, we need to make sure that we already have an established process for bringing open source software to the firm. Let's leverage that, right? Same thing for data, same thing for data use and data loss prevention. So just leveraging all of the controls that we have built over time for software security in the appropriate fashion just gives us that baseline, that baseline security. And then we're having those advanced conversations with them around, what the playbooks that we have to build, what are we looking for? What are we, in the business context? Because a lot of, these models, when we start talking about that, we have to understand them in the business context. And that's one thing I've learned by talking to data scientists over and over again, and that, we cannot just come up, like the cyber guy cannot come up with an attack, an understanding of what an attack is and what I have to do, in response. This is something that we need to partner with, the business to get that understanding and work with them to sort of build that playbook and build those defenses. So I think that's, I believe, where we are. Going forward, yes, I think some of the most advanced stuff will become more important. But first, we need to get the basics right, and then there's a partnership with the data science team to build the data scientists to build the the advanced defenses for for cybersecurity and for business in general.
Great, thanks. Ram, anything that you'd add? Vijay? Ram, I want to come back to something that you brought up earlier. Something that's really kind of present today is the supply chain risk. So models being downloaded from open source repositories, for example. I'd like to just, in a few minutes remaining, as a really crunchy item that we all can, improve on, I'd like to do a few minute deep dive on that element. And I'd love to hear from you, Ram and Vijay, about what are the risks to software and code, data, models, and what we can do to mitigate the risks from those third-party, supply chain elements.
I first want to plus one what Yassir and Merritt, have been hammering down. Before you want to eat the chocolate of adversarial machine learning, eat the broccoli of, software security. It's like table stakes. Don't forget to do that. That's kind of like important. I think kind of like going down that message, I think there are multiple personas when you think about, especially open source software. There may be the admin who's setting up the environment that can allow what kind of like ML software could be downloaded. The thing that gets tricky here is that because so much of machine learning is now like based on open source frameworks and open source tools, it's really hard to kind of have a whitelist of here are the only tools that you can download into your environment or access in your environment. So whitelisting approach is going to be a little bit difficult. I think the two things that are, at least for me, are crunchy is first one, think of an inventory of the ML models in your organization. Think of the libraries you're using. If somebody, if Log4j, if somebody were to just come and say, oh, matplotlib has a vulnerability, you first need to understand in your organization how many ML systems use matplotlib library. How many of them actually have it? And without a robust inventory, you are kind of flying blindless. The second thing, again, for me, at least from a crunchy perspective, is there was a cyber EO that was issued in the US talking about SBOMs, the software bill of materials. I think it's a great application for machine learning systems. It's a good practice to just lay out your dependencies, kind of trace that out. And this should not be only a security, only a security practice. It should be like what ML engineers also start adopting. So for me, the big thing is it's kind of related. Inventorying and SBOMs would be the table stakes. On top of that, if you can do some sort of like specific like vulnerability scanning, great, but really start with having a robust inventory would be something that I would think about if I have to, like tackle supply chain in an organization. I'd love to hear what everybody else is also thinking about.
I'll go ahead and chime in here. I think this is all these are all really good recommendations and plus one around the table here. There was a question in chat, something along the lines of, well, most of us are just scientists and ML engineers and may not have traditional software development experience or backgrounds. And so we're very unaware of some of the best practices that may be there. So I thought maybe I could chat a little bit about the expectations that we set with maybe more of the research community who may not be developing something for production, but just maybe experimenting and or recreating or validating some of the things that may have been published in some journal or some paper, which we see a lot of, right? And so a lot of that, from a behavioral standpoint, you expect folks to pull down code. You expect folks to pull down data sets, and you expect folks to run effectively unauthorized or untrusted code that you have no idea where they come from, right? They could be in, maybe they're in GitHub or Papers with Code, or there's some other type of repository. But researchers need to do this. So how do you enable that? So I think that it's worthwhile to provide the underlying infrastructure that researchers too need to help them in their day-to-day operations and what they expect to have to do when it comes to conducting research, whether it's running experiments, validating code that may have been part of some state-of-the-art work or research that was done in some paper that was just published. And how do you enable that research to go faster? And so if someone does need to go and execute some code, or what does infrastructure look like to run untrusted code in your environment that's completely separate from what the actual developers or engineers may be doing? I think having the ability to do that, one, in a very structured way, so providing them the tooling and environments they need to go and spin up a collab or run some underlying kernels, or maybe executing some untrusted code or accessing data in a very specific way. So if these are the external data sets that you need to have access to and experiment with, they're all going to sit over here and live here, and this is the way that you access it in a safe and trustworthy way, if that makes sense. So I think a lot of that is extremely important. On the dev and eng side, I think we've kind of went around the board here to cover a lot of good best practices and a lot of references as well. So I won't speak too much there.
Thank you, Vijay, and thank you to each of our panelists, Merritt, Ron, Vijay, Yassir. Thank you for your insights and recommendations. I think that's made the feeling of being nascent in security, made it feel practical and real for us. We're going to conclude our session today.